Hello everyone. Today I shall discuss about heat or energy budget of the earth. You know, what is heat? Heat is a form of energy which is also known as thermal energy. So when I talk about heat budget of the earth, it means I am talking about the thermal energy or energy budget of the earth. So we can say that both heat and energy budget are same. Now, one question which comes in our mind that what is budget? Budget is an estimation of input and output. This is important to maintain stability or balance in the system. Suppose if you earn 10,000 rupees per month, what it means? It means you cannot spend more than this. It means you have to manage your earning and expenditure to make a balance, or otherwise you will get in deficit. Now, let us discuss what is heat budget of the earth. This is the statement of the total incoming shortwave solar radiation and outgoing long wave terrestrial radiation from the earth. On an average, there exists a balance between incoming solar radiation and outgoing terrestrial radiation. If this balance is disturbed, you know what will happen? The earth would become progressively warmer. Suppose this is earth and this is sun. If earth is receiving 100 unit of energy from the sun and it is reflecting or emitting back only 50 unit, then you know what will happen. Still 50 unit will remain with earth and its atmosphere, which will further enhance the temperature of the earth. Due to this, the entire cycle and thus whole ecosystem will be disturbed. Now, there are certain things you need to know for better understanding of heat budget of the earth. This I will cover under basics of heat budget. The first thing is relation between temperature, energy and wavelength. We can think of radiation either as waves or as individual particles called photon. The energy associated with single photon is given by, E is equal to h nu. This is equation 1, and here E is energy associated with photon, h is Planck's constant and nu is frequency. The value of h is 6.626 into 10 to the power minus 34 joule second. Now, we also know that there is a relation between frequency, wavelength and speed of light, and this relation is C is equal to nu lambda. This is equation 2. Here C is speed of light, which is constant. The value of C is 3 into 10 to the power 8 meter per second. Nu is is frequency, lambda is wavelength. Since this C is constant, so we can say that nu and lambda are indirectly proportional. So, putting the value of frequency in equation 1, we get E is equal to h by lambda. Here h is constant, so we can say that energy is indirectly proportional to the lambda or wavelength. It means longer wavelength will have less energy and frequency, whereas shorter wavelengths will have more energy and more frequency. Now, according to Wien's displacement law, the hotter object will emit shorter wavelengths and cooler objects will emit longer wavelengths. You know, the temperature of the sun is around 6000 degrees centigrade, whereas the average temperature of the earth is 27 degrees centigrade. Now, since the temperature of the sun is very high, so it will emit shorter wavelength like this, which will have high energy, and so they can penetrate our atmosphere. But the temperature of the earth is less, so it will emit longer wavelength, which will have less energy, and they cannot penetrate our atmosphere, rather they are absorbed in that. Now, second, interaction of solar radiation with atmosphere. There are three major types of interactions which takes place between solar radiation and atmospheric components, that is gas, particulates and clouds or vapors. The first is absorption. Certain short wave solar radiations are absorbed by the atmosphere and are re-emitted later in the form of long wave radiation. Second is reflection. Sometime what happens, the atmospheric component reflects the short wave solar radiation back to space without any interaction. And the third one is scattering. Sometimes the particles and the gases of the atmosphere scatters the solar radiation. Based on wavelength and the size of particle, the scattering may be of three types, that is Rayleigh, Mie and non-selective, which we will discuss in our later lecture. Now, third one is interaction of solar radiation with earth. After absorption of short wave solar radiation by earth, it is re-emitted via three ways. The first one is evaporation as a latent heat of evaporation, and second is convection. Convection means movement of energized molecule from one place to another place, such as air, rising of air due to heat. And the third one is emission of thermal infrared. So, these are the 3 points which are important before knowing the heat balance of the earth. Now, heat balance. The earth receives 2 billionth part of the solar radiation, which is less than 1% of total solar radiation. It was G.T. Trivartha who proposed the heat budget, in which he considered the total incident radiation at the outer margin of the Earth's atmosphere as 100% or 100 unit. Now, let us consider both the incoming solar radiation and outgoing terrestrial radiation. Here you see, at the upper surface of the atmosphere, suppose if solar radiation is 100 unit, then out of this 100 unit, 35 unit is albedo. It means it is reflected back to space without any interaction. It has no role in the thermal process of the earth. It is as such reflected from the atmosphere. Now, when we see this 35 unit of albedo, we find that 27 unit is reflected by upper clouds, 6 unit is scattered by upper atmosphere, and 2 unit which reaches to the ground is reflected back to the space by ice caps. So, this is the albedo of the earth, which is equal to 35 unit, and it is not used in the thermal process of the earth. You know, the temperature of the earth and the albedo is indirectly proportional. If there is less albedo, then the temperature of the earth will be more because it is absorbed rather than it is reflected. And if albedo is more, then the temperature will low. Now, after subtracting this 35 unit, we have only 65 unit with us, and out of this 65 unit, only 51 unit reaches to the ground surface. Remaining 40 unit is absorbed by cloud, which is later re-emitted to the space. Now, outgoing terrestrial radiation. Our Earth's surface receives 51 unit of solar radiation. Out of this 51 unit, 17 unit is emitted back to space without any interaction, and the remaining 34 unit is emitted in the atmosphere. From this 31 unit, 19 unit is emitted as latent heat of evaporation, 9 unit as convective wind, and 6 unit as radiation, which is later absorbed by carbon dioxide, which causes global warming. Now, the heat balance sheet. You know, total incoming solar radiation is 100 unit, and the total radiation back to space, the first is albedo, which is 35 unit, cloud and atmosphere is 48 unit, that is 14 unit by cloud and 34 unit by atmosphere, which is 48 unit, and then ground emission is 17 unit. When we add all these, we will get 100 unit. So, net heat balance is equal to gain, that is 100 unit, minus loss 100 unit, that is 0 unit. So, that is all about heat balance of the earth. Thank you very much.